Okay, so we should be now, we've run through our base plotting, and hopefully we know enough to do a certain subset of plots. We can save them just to file programmatically, or we can save them using RStudio deposit setup. Again, base graphics is great, and it can be fast. But already we had a question which straight away led to our second session, which is ggplot. Okay. So I don't have the usual setup slides here. That's strange. Okay. So as we've seen, hopefully R has extensive graphics capabilities, and you could get lost in base plotting for years. Graphics in R may be created by many different methods. That's true. So base R on the left, that's quite a complex plot already, at lots of points. But we have advanced plotting structures, packages such as lattice, which allowed us here. It's kind of grouped things by depth, bins of depth. It's plotted sub values, what needs XY value would be for these kind of substructures. So already, this is kind of the three-dimensional you were talking about. So how can I overlay a third variable onto my simple 2D plots? Simple. We can either make facets, or we can start to play around with the aesthetics within that plot. Okay. So ggplot 2, I never came across ggplot 1. ggplot 2 was written by Hadley Wickham to provide, I say, a really intuitive plotting system. So I'm going to give a course on this. It's going to be an hour, but everything you need to know, you'll probably pick up in the first 2 minutes. Well, we've got an hour worth of course. That said, we're really going to talk through some of the finer things. So ggplot 2 itself builds on this concept, which I've never seen the Burton stuff, but I've looked at the Wilkinson. There's this concept of a grammar of graphics. Right? So you have a consistent syntax which will allow you to construct a wide range of complex plots, graphics, by a very simple description of their components. Okay, so we should have the ability to make a bar plot, a box plot, a line plot, a dot plot, should all be very similar. Right? I shouldn't need to use a different function, bar chart, we saw earlier, histogram. Right? We should be able to have a more consistent syntax, which will allow us to rapidly prototype different plots. Okay, I want to look at my data like this, that didn't work, I want to look at it like this. That shouldn't be really what takes your time. You should be concentrating on just reviewing the data, looking at the plot, right? Don't get me wrong, you can make some beautiful plots, add all sorts of complexity to it, but using visualization to get an understanding of your data, we want to make that quick and easy. So ggplot is actually a part of the core tidyverse set of packages. Does anyone know what tidyverse is? Oh, geez. Oh, wow, you're in for a treat. Tidyverse is a set of packages really make data science easy and more functional. So it's another style of using R. And we have a course on it, and the reason we're not covering it in here is because base graphics is what everyone uses. Sorry, base R is what everyone uses. So it's all built on top of that. Tidyverse is an ever increasingly popular set of packages, but not everyone uses it. So I said earlier on, we have reference and we've seen help. Right? If you do question mark, we see the help, we see the vignettes. Those vignettes are always written using base R. They're not written using tidyverse. So we need to know base R. And I can tell you, you're going to get majority, 99% of everything can be done just using base R. And in fact, everything can be done. It's just tidyverse is a slightly different way of doing it, which they would say was more intuitive. Okay. So one part of tidyverse, which I think is just undeniably fantastic, is ggplot. And that's really what we're going to concentrate on. But there is a link here. If you want to go to the tidyverse materials, it's fine. If you want, we can also bring Matt in. We can do a little bit of an extension to maybe one of our sessions, and he can hang around and teach you a bit of tidyverse. Just let me know. If I get a few people, we'll do that. So actually, I want to show a little bit about these guys. So let's have a look. What have I got open? So ggplot itself. So most of the time I'll say question mark function will give you the answer. ggplot's actually one of the few packages it's worth going to their I'm sure it's worth going to their pages anyway. But the reason why it's so good to come to their pages for help is their help pages will actually contain plots, okay, which is really useful for when you're making plots, right? The output of the plot is displayed in the help. When you do question mark the name of a function, it doesn't have a mechanism to show you the plot inside the help. That's probably being updated soon, but right now, no. So ggplots, yeah, it's very popular. The guy who actually wrote ggplots, this guy, Hadley Wickham. Hadley Wickham is amazing and changing kind of how R works. He now works at RStudio Posit. He's also a professor. And he's done some packages we'll be kind of excited about. We're going to use ggplot. Lots of our packages here. I heard someone talk about C++ earlier on. Maybe you guys, there's a fantastic interaction for R and C++ called Rcpp. He's written a book on how to go and do it. So if you really get sick of R being a little slow, you can use our C++ super easily under the hood, just using some of his tricks there. Again, this ggplot is part of this big tidyverse package. And probably the one which you will come across at some point is dplyr, which is a way of manipulating data frames. We know data frames are base to R, they're essential, so that's really useful. But he also has packages to read R, so reading big data, manipulating strings. tidyr, I think, is to do with tidying up data frames, cleaning up your data. Tibble is an alternative form of a data frame, which he likes, and it gives you a little bit more functionality. And then per, and I think there's another one which is very similar. This allows you to do things like parallelization, split up parts of your data. So just to give you an idea of, and obviously this, our infrastructure. So this is a set of tools which are very, very useful in R. And as you begin to take R seriously, you will start to come across more and more of these packages. These people aren't R-based. They don't work for R. They work for RStudio and Posit, but they're writing the packages which we all use. So this is kind of a nice example of the community in R as well. Right? These guys open. I can look at every single part of their code. I can contribute. I can ask issues like you can ask questions of us. I can ask questions of them. So it's a really nice little community. I don't know why I put Rlang. It's something which I really like in R. So it allows you to build more R from R. But just to give you a nice idea of the popularity of ggplot2, I just want to check my slides quickly before I jump ahead. Yeah, so I'll come to this in a second. So the nice thing about ggplot2, with this grammar of graphics, is it does provide this syntax, this high-level abstraction, which should allow you to concentrate on the actual plot you want. What type of plot is most useful to me? What's best going to visualize my data, rather than how do I create that plot? So for instance, you've asked, how do I make my points, say, scale to the size of the data set? You would have to write that yourself in base R. It would take a while, right? To do that, as you'll see in ggplot, is one line, maybe change 2 words in the line, which is exactly what it wants. Concentrate on just making the plot as intuitive as possible, not being a great coder or knowing what's going on really under the hood. So their kind of central philosophy is taken from their website, I'm sure, is increased flexibility over other plotting systems. So we're no longer pen and paper. We have a lot more flexibility. An advanced theme system, so you can actually make these plots with a few lines look really pretty as well. I would say really pretty. You're still going to take them to Illustrator and make them tidier, but they look really nice out of the box. There is a large user base now. So like I'm saying, I use ggplot. Everyone in my team uses ggplot. Pretty much everyone using R professionally uses ggplot, right? So you're going to be able to ask your friends, colleagues. You're going to go online. You're going to find lots and lots of help. If you use a stranger, rarer package for these types of things, guess what? Not many people are using it. You may be the first person to come across that problem. You may be the one who has to solve it. ggplot, I assure you, most problems have been dealt with. There aren't many bugs left. The last thing is this large developer base. So, we write a few packages in R, Bioconductor, and we build off ggplot. So we take it as a dependency for how our data works. And the reason is, as you'll see later, is because unlike pen and paper, that means a tool I write, a function I write can give you back a plot, which you can then edit. Right? It's not just me making a plot and then that's how you take it. It will give you back the object of the plot, and then you can edit it, change the colors, and that's much more useful. And this is why people have really invested in ggplot. So the good thing is, even if you don't want to use ggplot yourself directly, by learning some of this stuff, you're going to be able to take other people's tools, packages, the output from them, and kind of manipulate them again. So just to give you an idea of this, I find this kind of stunning. So this is a standard package. I'm not picking on whoever wrote this package, just make sure it's no one at Rockefeller. Nope. Okay. Roche. Okay. So this is an object-oriented. I don't even know what this does. It's just a package I chose at random, but it has some interesting things here. And we can see that what it has is imports, suggests. Okay, so these are packages which it relies on. So it itself relies on, or actually depends on, which is an even stricter level of a needs, ggplot2. Okay, let's actually pick another package because this one doesn't have any packages which depend on them. So let's try Rcpp. That's sucks. I'm trying to find a package which is less well used. Okay, here's a good one. So then, whereas this is the packages maybe that depends on, so this package in particular depends on very little, just that in this package called Coda, you can see here all the packages which rely on it. So all these packages, when they build, they need whatever this is, are JAGs to allow it to work, right? They're using that within their system. So let's have a look at ggplot. So ggplot, it imports a few other things, including rlang and other tools. They kind of write a lot of small packages to feed themselves, these people. But if we look at the packages now, reverse depends, and this is like essential. It's a ton. It's a ton. Thousands. They are built on top of this. And so learning a bit of ggplot now, you're going to be able to use the output from all these packages. So that hopefully shows that this is worth investing a bit of time, your time in, and I assure you, you're never going to be alone with any problems with it. People will be there to support you. Okay, so how does ggplot build it? Right. So in this case, what we do, and this is just a very graphical overview, is it takes your data. So here we have, say, a data frame, and we have columns: height, weight, BMI, sex, pet. So they're across the top here. And ggplot applies what is called aesthetic mapping. So this will be AES in short, but aesthetic mapping. And it maps these variables in the data frame to features of your plot. So actually weight will map to, say here, the x-axis. Height will map to the y-axis. Now we can start to get into this kind of 3D part where BMI, for instance, maybe we'll map that to color. Sex will map to shape. If you have pets, you'll have different sizes, right? So we can actually, this is going to be a very complex plot, but we can overlay a lot of information in one plot just by mapping aesthetics, columns in your data frame to features in your plot. That's called aesthetic mapping. On top of that, we need to add a few things. We need to add scales. So what's the scales of your data? We need to add maybe statistical transformations, logarithmic changes, etc. Importantly, we need to add Geom. So a Geom is the type of plot we need. So we'll have a Geom box plot, we'll have a Geom line plot, Geom point plot, and we need themes. So themes are data independent, it doesn't matter what data we have, but a theme, an annotation, plot annotation, this is kind of how the data look, how the plot looks. So do you have a background as pink? Do you have a background as gray? Do you have no background? That's all contained within the themes. So if we look at everything which then kind of goes into a ggplot, it looks a little complex. So we have to give it data, we have to give it aesthetic mappings, We have to tell it the geom we want to use. Here I'm using a scatter plot. We have to give that additional information. We need to tell it any scales we're using. That's complex. Give it a title, give it X and Y lab. So potentially, there's a lot of complexity within a ggplot object. But actually, you don't need to know much about that. You just need to be able to set a few things, and the defaults will do lots of sensible decisions for you. So really the most important thing you need to be able to do is decide what you want in your aesthetic mappings, how your data will map to the portions that type of the aesthetics of your plot, the X, the Y, the shapes, the colors. And you need to specify a geom. It needs to know what type of plot you want. Those are the very basics. Themes, scales, stats, that is all taken care of under the hood by default. So then this is the line where you can just walk away. But really, to make a very complex ggplot, it's very simple. We have a data frame here called patients clean that contains these columns I mentioned. And then I would provide to this, so we have ggplot is our function. We provide an argument to data. And then this is a little complex, but hopefully with practice we'll get it. We do a comma, and then inside the second part of our function, we provide these aesthetic mappings. And we do that by doing AES, and then we provide within here Y. So the Y-axis, we want to correspond to weight. X-axis, we want to correspond to height. Color to sex, size to BMI, shape to pet. So that sets up our ggplot, and then I tell it plus, and I give it the type of geom I want to plot. And here I want to do a point plot. Okay. So we're going to build our ggplot here, and then we use a couple of weird things, but we're going to do plus here, which I haven't seen before, but this is particular to ggplot. We do plus, and we add additional parts to that. Okay. Remember, this is all held in memory. It's only written at the last part. Okay. So we have an object behind this, and we'll see that in a few slides. Another thing worth noting here, which is very strange to people, I think, originally, is none of this is quoted. Right? I'm taking column names here, but I'm putting weight unquoted. I'm putting height unquoted. Right? And this is because ggplot has a slight special technique here where it doesn't need you to quote. And actually, if you try putting quotes around weight, it's going to break. Right? So it wants that to correspond directly to the column. Okay, so the next few slides, I'm going to build this up to show you a little about the inside of the object. But again, you don't need to know that. I just want to show you this to kind of hopefully give you a slightly deeper understanding. So we have some data. I think it should be available in the data column. We need to read that in. So first, we're going to load ggplot, not necessarily need. We can read in the patient's clean object from a data frame, a text object in our data directory. I just need to tell it it's tab separated. I think read to lim, maybe that would have been default. And then I get a patient's clean object. It's a data frame that has 100 rows and 17 columns. And if we just look at the first two lines, you can see here we have things like ID, name, race, sex, smokes, height, weight, birth, state, pet, grade, dye, count, date entered, age, BMI. So, we mentioned this before, but by default, R will read in everything as a data frame. These are great for ggplot because we can mix our numerical and our character and our categorical data together. So here, if we look $smokes, remember I can use $ to take out a particular column. I can see that we have characters for that column, non-smoker, smoker. Maybe that would be better as a factor. Right now, it's a character. And we also have a column height, and that's all numeric. See where it's all. We can quickly get a summary of our data frame, remember, by using the summary function, and this will just tell us really what types of data, slightly a little bit about the distribution of the data maybe. But we can do summary patients clean, and we can see that most of our columns are character columns. R no longer reads characters as factors, so they're all going to be characters, apart from those which were numeric, height and weight, which maintains the numeric. So as we saw previously, the minimum we kind of need to produce a ggplot graph is the data to be used in the graph, how we map the data to the graph, and then what type of graph we want. So the first thing we can do is just create an object which has none of the other components. We're just going to give it our data. So I can do ggplot, and I can just give it my data, and it will produce an object, which if I check the class is actually a ggplot object. But it's still fairly useless to me. I can't do anything with it yet. It's got no aesthetic mappings. It's not no geoms. Within that ggplot object, so once I've created this object, I actually have all the data stored internally. Right? And it needs that if it's going to be able to rapidly regenerate and iterate through plots. Right? This isn't pen and paper. It's not writing it to the thing yet. It's holding it in memory. So already we can actually look inside a slot within our object, and we can see it has a data, and that contains all the data which we just passed in here. If we look, though, in other parts of this object, and there's a mapping component, if I look $mapping, I can see I have no aesthetic mappings available. I haven't given it any. If I look at the theme, I can see it's got a list. It's got nothing there yet. If I look at layers, layers correspond to our geoms, our types of plot. You can see we have nothing there either. So, no use yet. If I want to, then I can start to add things to this plot. Right? So rather than adding it to the paper, pen and paper, we're adding it to the object. And it's a similar concept. I'm just adding it to the object. So let's do our ggplot. We'll give it the patience clean, and we have our object we just saw. But now I'm going to take that object and I'm going to add to it some aesthetic mappings. And so I'm going to do plus AES, x equals height, y equals weight. If I look at the object now, we have actually something within that mapping slot. Right, we have this $mapping, and we can see it says, okay, it understands the aesthetic map, x to height, y to weight. Right? We don't know what type of this is. We can't really interact with this beyond that, printing it, but it's telling us some information there. X is mapping to height, y is mapping to weight. We still don't have a theme, and we still don't have a layer, right? And the layer is a really important point. So we need to know what type of plot we're going to do. It's okay if I say all these mappings, x to layer y. But if I want to do a line plot or a scatter plot, I don't know yet. So the last thing I need to do is add a geom type of plot. So here I'm going to redo my data. I'm going to do my aesthetics again. And finally, I'll do plus, and I'll add the type of geom I want my plot to be. So now if I look at it, I have mappings. I know I already have the data, but I have the mappings. I still don't have a theme. But we don't actually need a theme. There's a default. And I have in my layers a list. And the first element in the list is my Geon point, my type of graph I just set here. Now, if I just type in PC plot and press enter in the RStudio, it will then cast the plot to my plot window. And it will look like this, where we have my data. And we have weight here on the y, so I corresponded it to y. X will be the height. And then I've got a Geom point plot that I asked for. I've got a point plot. And I've got other things I haven't asked for. Background, lines, axes, etc. So there are a lot of options for geoms available to us, and I'm just going to step through them now. Okay, so this is a little repetitive, I think, this part, but hopefully it illustrates just how quickly we can move between these different types of plots. So one thing to point out here is previously, or just to show you in these things, I've done plus AES, right? So I've added it to it. You can actually provide it to the ggplot function as a mapping parameter. So here I give it my data, I give it my mapping, and I tell it my aesthetics are within brackets, x is height, y is weight. And then I can just do PC plot plus Geom point, and now I have my point plot. Okay. Similarly, if I want to turn that into a Geom line plot, I actually don't need to rerun this, right? I am doing it here, but that's the same line as I had here. I can just do PC plot plus Geom line, and I've taken the same basic data ggplot data frame with all the aesthetic mappings, and I can produce a line plot from it. If I want to, without changing anything in my PC plot, I can also change it to a smooth line. We're going to come back a little bit to that later. PC plot smooth. And this is also an example of it doing the stats for us under the hood. I haven't asked it to do any stats, but it's provided it's doing a low S, so it's fitting to a line, following this formula, it's giving me a standard deviation. How do the fitters? So it's doing that under the hood. All I'm changing between these plots is my geom. Okay, so once you built that that ggplot object, you can rapidly say, well, what looks best? Okay, let's fit a smooth line. Let's change my smooth line. If I want to do a bar plot, I can. And I can just do plus geom bar. Okay, in this case, I'm going to set X to be sex, because this is going to do kind of a frequency thing for me. It's going to see how many of each sex do I have and create here a count on the left. And then, the different groups, male and female, and then male along the bottom. Okay, we're going to come to the fact, how do I control that order? Female was first, male was second. We're going to be able to control that in a bit. Similarly, if I want to, I just need to, really, I can update this aesthetics here, but with very little change here, I can change this to a geom histogram, right? Just plus geom histogram. And it again does some statistics for me, tells me what I could change. I can change the bins argument. But in this case, it's done this for me, and it's kind of created the distribution of my data. Similarly, I don't need to change anything now with PC plot. If I wanted to, I can just do plus geom density, and I'll get a density plot. Again, it's done some statistics for me. It doesn't give any explanation of what it was, but under the hood, it's made a density plot for me. Finally, last two we can do is these box plots. Again, I recommend if you're going to do a box plot, probably base is faster for your data. But we can do that very easily here. We just create our ggplot object. We have our patient's data frame, our mappings. And here I'm going to say along the x-axis, I want the sex. I want to group it by sex. I want the y-axis to be height. And now I can just do PC plot, same structure, but plus geom box plot. And I'll get a box plot. Exactly the same setup. I just need to change to a violin plot, geom violin. And I guess something I actually like violin plots a lot more because it's kind of like a density plot. It's the distribution of my data within my two groups. Whereas this kind of didn't really show that, just told me the median. A violin plot told me that this is a much bigger spread, really, while lots of this data is in here. So hopefully amongst that really is just to show you how quickly we can iterate through different versions of geoms, different versions of the plot with the same basic syntax. Right? We set up our data frame, we create our ggplot. Data is what with the data frame, we describe the mappings, how we want the data to map to our plot, and then we just tell it the type of plot we want. So we should really speed up the way that we can work with data. But we saw on base graphics, if I wanted to use a dot chart, I needed to rotate my data before it went in. Right? Some of these things had different arguments. Names.arg for one, xlab for the other. This will provide a consistent syntax across all my different plots. I just need to change a few things to move from geom box plots to bar violin plots to bar plots to x plots, xy plots, line plots. Very cool. There are a whole world of geoms. So I think the best place to look is in ggplot documentation. Not sure where that kind of came up. Maybe that's the ggplot documentation. Somewhere in here. Packages, profiling, extended, customization, fasting, access, reordering. They will have examples of every plot for sure. Maybe it's in the other one. Yeah. So here you have a nice complete list of all the potential geoms you can apply with ggplot. Remember, ggplot is a package, and people have built packages on top of ggplot. And so when we come to, say, looking at your genome, your genomics data, we can use a genomics data package which uses ggplot under the hood. Right? And it will be able to build things in the same way, but they will have a geom track plot or something. Right? They will add additional geoms for you, but it's the same basic structure how you set it up. So lots of geoms, a whole world to discover there. So the next thing we want to look at is how we can control the aesthetics in our plot. Right now, we've just done X and Y, which are basic aesthetics. But clearly, we can build up very complex plots and very little effort on our part. So in this case, we're just going to start very simple. We'll just set a constant color. So similar to base R, what happens if we want to change all our points to red in this case? So here I'm going to do ggplot, patience clean. I'll give it an X and a Y. And I'm going to say Geon point, but I'm going to provide within the Geon point argument, additionally, another argument, color. I'm just going to say is red. Hadley Wickham's Australian. So color, we can spell with a U or W. And actually, Hadley Wickham does this across all his packages, which I kind of appreciate because I get a little lost on this. So you can use British or American spelling, no bias. I know it's just I'm going to mix and match between, I think, as I go. So as I said earlier on, ggplot makes use of aesthetic mappings to assign your data frame columns effectively to these aesthetics, these features in your plot. So in this case, here, this is one we saw earlier on, we're just mapping very simple aesthetics. We're going to say, given the data frame, map to the x-axis height, to the y-axis weight, right? And then we did Geon point, and we had a very simple graph. Oh, then I make a point of color. Actually, we can just adjust this plot from before very easily by adding now X is height, Y is weight, but color it by the sex column. Okay. Now, if I do plus Geon point, it's done a lot of those things for us. First off, it's chosen the colors for us. It's not just made colors. It's like it's chosen the color scale for us. We didn't need to set anything. There were no parameters, color palettes provided. We can, but by default, I can't remember what it uses, but it uses a very sensible color palette. So you're going to get distinct colors. Another thing which it does, which is super cool, is it gave us a legend. We didn't need to ask for it. We don't need to say top right, top left by default. It gave us a legend. And if you remember earlier on, it's actually able to give us multiple legends right next to each other. It will arrange all this for you up front before it prints it to the screen. Okay. So similarly, if you want to do shape, I can just press very easily, again, similar syntax. I just change AES and put shape now as the sex. And rather than having colors, it's chosen default shapes for us. Male, female. No surprise, male's way more, generally a little bit higher. So very cool. The aesthetics mappings can also actually be directly set in the Geon Points function as well. So previously we did this with setting color is red, right? But we can also, if we have our PC plot, which we build up front, right? So we've done that, and that's our base GG object we want, ggplot object. We can then just make the changes for aesthetics we need in the actual call to Geon point. So here I'm going to set the aesthetics within Geon point, and I'm going to use that aesthetics function. I'm going to say X is height, Y is weight, and color is sex. I really am flipping between the two uses of the thing. I don't know why. Okay, so but again, it doesn't matter which way we do it. It's very consistent syntax, but we can do it either way. Whatever's easiest really for you once you've built your ggplot object, but it gave us our legend for free. I could then, perhaps this is a nice example. I can then just change my Geon point. I change one bit and change the color to smokes. And now I've got non-smokers, smokers, which isn't quite such a bias. We'll wait till we get to the death bit, and then there's a bit of a bias. But then I can start to do nice complex plots already. I can add color for smokes, shapes for sex. Maybe we'll do better like that. It's done our multiple legends. Of course, we're going to see later on, we can control the legends and we can put them in various parts and we can control, all that's controllable, but by default, it's done a great job. And now, if I want to, I can start to do things like Geom violin. So here I'm going to say, this is really smart. X is sex, Y is height, and the fill is smokes. Okay. So now it does something even cleverer. It's not just the X is height and the Y, sorry, X is sex, Y is height. So female, male, height. It's also starting to do subplots. If we say fill equals smokes, it wants to fill, wants two categories then, it wants to fill the colors. So it automatically knows we want to break up to non-smokers and smokers within our categories running out. So it's done a really maybe one argument change, and I can change the whole block. Again, for a comprehensive list of the parameters and aesthetics used in Geom type functions, so if you're ever confused, what can I actually use in a Geom? Right? Some things naturally won't work with, say, X and Y. They're one-dimensional histograms, for instance. Right, so you can do question mark and the type of Geom to know what parameters you can set. And of course, there are lots of help here. I think my R is hopefully still up, so I can have a look. See how useful that is. I was wondering actually if they have updated the help to put the graphics in, because remember, Hadley Wickham now works for Posit, our studio, so we might have forced them to do that. ggplot 2. So in this case, I want to look up Geom box plot. Do I get graphics? But you can see, because these people are, I don't say professionals, but I'm sure we're all professionals. But they really give a great description of all the different arguments and then all the aesthetics which you can set are really well explained. Required aesthetics are set in bold. Right? Some of these are set by default. But... So I can change, say, the line type around the box plot. Right? And change the fill. There's a difference between fill and color. I think we're going to show this later on. But when I ask, say, a box plot, I give it a fill, it's the middle of the box plot. If I set the color, it's the edges, right? So you can have red edges and blue middle. Okay, but really to say all of this is very customizable, lots of aesthetics. And again, it says here, some of this is actually calculated internally, and that will be the statistics part of it. It's going to calculate the min, the max, where you should have outliers, all that for. I'm actually going a little fast, but maybe that's good. We had a long session one. Okay. So something we saw with lattice graphics, just in the demo I showed you, you have three kind of panels, right? That's a really useful thing to do, especially for things like XY plot. You want to have maybe different panels for your different groups. Maybe bin your data, and then, you know, my smallest people have this kind of effect. Maybe proportion of smokers is different when we look at the biggest people. We can control facets in ggplot really easily as well. Just by using these two functions, I think these are the two functions, maybe more, facet wrap and facet grid. So this is going to allow us to subset by a variable in our data by a column and split our plots up by that variables in the column, the categories in those columns. Facet wrap's a little bit more free form, so it's better for, like, if you're just faceting your data by one variable. But if you want to have a faceting by two variables, so maybe I want sex across the top, and then gender or sex, sex across the top, pets here. You know, I can do that better with facet grid. See that in action here. So facet grid, the format for kind of saying how you want to break up your data is you put what you want to put in the rows across here. So I want my rows to be made up here of whether or not you're a smoker. And columns, I want it here to be sex. You can see it does that just for me. It puts female, male, and then non-smoker, smoker, this way. There we go. Again, we're going to come to the fact that why is female, then male, why is it non-smoker, then smoker. Has anyone got any guesses why it's coming out in that order? Good, because it's going to be exciting in the next few slides. Do you have a guess? According to... No, not quite. We'll get there, we'll get there. So in this case, yeah, facet grid, smokes by sex, and I got there. So we have a new element here, which I'm just going to say this. So these things here are actually called the strips. You don't need that later on. Color vector. This part here, where it's a label for the facets here and here, these are called strips. So you can see it's not something clever, it puts male, doesn't put another one there. We can control what side and all this later on when we look at themes. But by default, that's enough labeling to allow us to know you're a male smoker, female non-smoker. Right? I can also just do by columns if I want to. So here I'm just going to do tilde. I think that's tilde. Columns. I don't put anything in front. So here I'm going to do by sex, and I'll get female, male. If I want to do rows, however, I have to do a little trick where I do the rows, dollar, and I have to put it tilde, and then I'll put a dot. Otherwise, it's just going to break. I'm not sure why. But in that case, now we'll have female, male this way. Facet wrap. I'm not sure I've got the best. Oh, yeah, here we go. Facet wrap is really better for when it's not necessarily rectangular. Okay, so it's going to try and fill in your screen from left to right as much as it can with the different groups you have. So facet grid, as you say, as it says in the name, it wants a grid-like structure. Facet wrap is better for kind of freeform. So in this case, I'm just going to go facet wrap by smokes. And it's going to work from the rows, and we'll have a non-smoker first, and then the smoker second. What's a nice kind of feature of this is you can actually use like multiple variables in combination just on the fly. So if I want to, and this is a horrible plot, and I realized I couldn't really fit it on the slide, but if you want to, and I want to break up all my plots by multiple columns, I can do facet wrap, dollar pet plus smokes plus sec. Now my thing in that order, cat, and smoker. Then we have our plot, obviously, branch down to something awful. So that's a very quick line to create what is actually quite a complex set of plots. I think if you did that in base R, you'd have to loop through your data frame, you'd have to subset down, make the plot, make sure it's all together. You'd have to add all these labels. It's complex. Right? ggplot, you're doing this in 2 lines. And then you can do, because that was awful, right? But you could actually make this something more sensible by doing facet grid. And here I will do a combinations again, but just in one of them. So I'm just going to do combinations across the columns. So non-smokers, smokers, sex and pet, and we can look across there. I can't see any correlation, but okay. So just this final last little bit, I think, is this part on plotting order, which is what I was just asking. Right, so for every time we've done these plots, it has given us a default order, usually female, male. Non-smoker versus smoker. So if you look at that, you would think alphabetically. Right? Non-smoker became smoker, which is kind of half of the problem, well, half of the issue. Not a problem. So here again, we do a box plot. I'm doing X is sex, Y is white, Y is weight. Not just the legends, but the order in the box plot. Female came first, male came second. And again, you can say it's something to do with, just by looking at it, you would guess this is to do with alphabetical. Yeah. Well, that's not a great slide. I'm sorry. But actually, it's to do with factors. Okay, so every column in a data frame is actually a character string. This is updated, I guess, since we first did these slides. I know. But what happens is internally, when it takes a column, it turns that into a factor. Okay, so if it looks at characters and wants to turn that into a factor, because that's kind of what you're doing. You're grouping by different sex, going to make them different colors, different types of pet. You're going to give them different shapes. So when it reads that into R, actually in this case, that column wasn't a factor yet. It was still a character. But when it got read in, it got turned into a factor, and by default, factors order the categories alphabetically. We saw this in our first kind of sessions. So we can actually fix that by just reapplying or refactoring that particular column. So in this case, I'm going to explicitly make it a factor by taking that column, giving it to the factor function, and setting levels here now to be male or female. And now when I make my plot, I'm going to get male first and then female second. So it is kind of alphabetical, but it's because under the hood, it's using this kind of factor rules, making it into a factor and just default factor, the levels are alphabetical. Okay, so that's really it for session one of ggplot today. I think I'll call it a day at this point. I think we're pretty much at the time anyway. Session one being a lot longer than session two today. I have exercises available for both of these. Feel free to just work through either one. I have a meeting in like 20 minutes. I'm just going to go stay here probably and just join the meeting. But let's give us an hour or so, and we can then start to look at the solutions together. So we can say maybe around 4:20, 4:30, let's do 4:20. And then we can go through it together. If there are people in the room and you're still going longer, then I can help people in particular, etc. But I'll be here at 4:20 to actually run through the exercises. Okay, are there any questions or anything at that point? Yes. Actually, we're going to come to this later. If I can hold off for a bit. Like, so it's not quite that easy. But we can add multiple jobs. Anyone here from the Fuchs lab? I'm really intrigued what our meeting's going to be next week. Do you guys know? Did you do a lot of C++? Or? Sorry, I totally overheard your comment. I understand. By the time you've written it, very well. What's really nice about like Rcpp is that he allows you to say you want to loop over a list. You can kind of convert the list to a C++ structure, and just the looping through the list is just that much faster. So it's actually really cool, and you don't need to know so much C++ because he writes kind of wrappers for it. I mean, C++ is so much. Did you ever look at C? Just pure C? It's a nightmare. All of, I'm not sure if you're doing gene express high throughput sequencing stuff. But if you're, are you ever gonna look at high throughput sequencing data? So that's 2%. Yeah. You want to interact with it in C++. I've had a lot of fun wrapping that into various packages. I'm going to go for a quick ciggy and then I got a meeting.